Good morning students. In the previous video, how to find the given system of equations by rank method. There will be a 4 case. The first case, hollow rank is 3, the system has unique solution. Suppose row of A by B and row of A is equal to 2, the lesser number of unknowns, it has infinitely many solutions. In the third case, suppose row of A by B and row of A, alloy is equal to 1, the rank is 1. Then the system is consistent and the system has infinitely many solutions. And the fourth one, suppose the ranks are differ. Row of A by B is not is equal to row of A, then the system is inconsistent and the system has no solution. Now you see the same exercise, the next model sums, using the values of k to find the solutions. Now you see the question, the same exercise, the second one. Find the values of k, okay, to find the values of k, for which the equations, there will be 3 equations. Some coefficients of x, y, z, the constant k is lies. Kx minus 2y plus z is equal to 1. Second equation, x minus 2ky plus z is equal to minus 2. And the third one, x minus 2y plus kz is equal to have no solution, unique solution and infinitely many solution. That means we put in which value of k the system has no solution, and we put in which value of k the given system has unique and it is infinitely many solution. First we understand when the system has no solution. The ranks of the augmented matrix and the matrix A, the ranks are differ, then the system has no solution. Second one, when the system has unique solution, both the rank means row of A by B and row of A, both are is equal to 3, then the system has unique solution. Third one, when the system has infinitely many solution, both the rank should be less than 3 and also is equal. It may be 2 or 1. The system has infinitely many solution. Okay, what is the first step? The first step to convert the given system of equation in matrix form. So we write in matrix form. The matrix form of the given system is. The matrix form is. You know very well, the first row is a coefficient of x, y, z in the first equation. Okay, it is the first equation. Whose coefficients? Coefficient of x is k, y is minus 2, z is 1. In the second equation, coefficient of x is 1, y is minus 2k, and z is 1. In the third equation, coefficient of x is 1, y is minus 2, z is k. Our next one is a matrix x, y, z is equal to RHS is the constant values. The constant value of the equation is 1, second equation minus 2, and the third equation is 1. Now it is of the form. It is of the form Ax is equal to B. That is, this matrix is called A, that matrix is X, and the RHS matrix is B. So the first step to convert the system of equation in matrix form. What is the next step? Using this matrix form, we find one more matrix. The matrix name is extended, that is augmented matrix. The augmented matrix is A by B. That is, the A matrix is extended by the another matrix B. First we write the values of A. Then we extended the another column by the matrix B. You see the values of A. It is the values of A. So first we enter the value k minus 2, 1. K minus 2, 1. Second row, 1 minus 2k, 1. 1 minus 2k, 1. Third row, 1 minus 2k. 1 minus 2k. That should be extended by the augmented matrix A by B is, we fill the matrix A by is extended by the another matrix B. Okay, it is the values of A. is extended by the another matrix B. The value of B is RHS 1 minus 2 1 is the value of B. Now we enter 1 minus 2 1. 1 minus 2 1. We write the augmented matrix. What is the next step? To convert the augmented matrix in echelon form. In echelon form is better to convert this element. First of all is non-zero. Your k is there. It may be 0 or non-zero. So we interchange R1 R2 or R1 R3 is your choice. We interchange anywhere. But I interchange R1 and R3 because you see some k is there lies. I interchange R1 and R2. The number same number is repeated. So I interchange R1 and R3. 1 minus 2 k. 1 minus 2 k 1. K minus 2 1. Now I write interchange of R1 and R3. R1 interchange R3. So the R3 become R1. You see 1 minus 2k and the extra one element is 1. So no change in the second row. 1 minus 2k 1 minus 2. And I interchange R1 become R3. So k minus 2 1 this one. So the first work is to convert that element is non-zero. It's better to convert in 1. Now I interchange R1 and R3. Or suppose sir I interchange R1 and R2. Okay, it's your choice. But we interchange R1 and R2. Here minus 2k is there. So number occur in this minus 2k. 1, 2 or 3 step is more. So I reduce the step. I interchange R1 and R3. What is the next step? To convert these two elements become 0. First we convert this element is become 0. You have any idea? We see so many sums. Just R2 minus R1. We separate 1 minus 1, it become 0. So no change in the first row. We write the first row as it is 1 minus 2 k and 1. So no change in the first row. And in second row we write R2 as R2 minus R1. We write the second row as second row minus the first row. We write R2 as R2 minus R1. 1 minus 1 0. Important here the value of k. We don't have the value of k. How to write R2? R2 minus R1. So minus 2k minus of minus 2. We write R2 as R2 minus R1 minus 2k minus of minus 2 is plus 2. So how to write? Minus 2k plus 2. Minus 2k plus 2 over. Now 1 is separate this. 1 minus k. Next one. Minus 2 minus 1. We write R2 as R2 minus R1. Minus 2 minus 1. Minus 2 minus 1 is a minus 3. So second row over. Next in third row we convert that element is also become 0. So we multiply the value of k in either R2 or R1. We multiply R2 or R1. Suppose I consider R1, R3 and R2. This R2 is multiplied by k. You see already one k is there. K into k is k square. The terms some more difficult. So I consider R3 and R1. Because just a number is lies. Minus 2 k 1. Our motive is to convert that element become 0. So I consider here R1 and R3. So it's R3 and it is R1. To convert this element is become 0. So this element is also we need k, but 1 is there. So the first row fully multiplied by k suppose. So the number 1 become k. Then to separate this k minus k become 0. So how to write R3? We write R3 as R3 minus k R1. Minus k R1. Minus k plus k become 0. So we write R3 as R3 row 3 minus k or 1. That is, we write the third row as third row minus k into first row. Now you see the first element. K minus k into 1 is minus k. K minus k is 0. Next, minus 2 minus k into minus 2. Minus 2 minus k into minus 2 is a plus 2k. So minus 2 plus 2k. Minus 2 minus k into minus 2. Minus minus is plus. K into 2. K2. Minus 2 plus k2. Next. 1 minus k into k. You know, k into k. We multiply. K into k is k square. So 1 minus k. 1 minus k square. And that element. 1 minus k into 1 is minus k. So 1 minus k. Okay. So these two elements become 0. Our next motive is to convert this element is also become 0. Because we need an echelon form. So this element is also become 0. Now you see the rows. You have any idea? It's easy one. Just to see, you have one idea. I don't change the first two rows. I write as it is. First row 0 minus 2k plus 2. 1 minus k minus 3. You identify how to write R3. Our motive is to convert that element is 0. After we convert these two elements 0, we consider only R2 and R3. You see, plus 2 minus 2. Minus 2k plus 2k. Just we add R2 and R3, it become vanish. So we write R3 as R3 plus R2. That is, we write the third row as the sum of the third row and the second row. 0 plus 0, 0. Minus 2k plus 2k vanish. Plus 2 minus 2 is also vanish, so 0. And that element. How to write R3? R3 plus R2. So first we see the value of R3. So 1 minus k square plus R2 plus 1 minus k. So there will be 4 values. 1 minus k square plus 1 minus k. And the 1 minus k become, we write R3 as R3 plus R2. Now we see the value of R3. 1 minus k minus 3. 1 minus k minus 3. What is the final value? Minus k. Okay, 1 minus 3 is minus 2. So now we see it is in echelon form. But some simplification is necessary because 1 minus k square plus 1 minus k. Some simplification is important. So we write the simplification. It is in echelon form, but simplification is enough. 1 minus k square plus 1 minus k. You know 1 plus 1 is 2. Minus k square and minus k. So you see there is one quadratic polynomial. We simplify because all are the needed the value of k. We directly put the value of k. But when we simplify, then only we get the answer. Suppose to convert in a factor form, then the simplification is an easy process. So we write 1 plus 1, 2 minus k minus k square. So the first two rows is no change. 1 minus 2 k 1. Second row 0. In 2 minus 2 k, which is common? The number 2 is common. So I will take outside 2. So I write 1 minus k. 1 minus k minus 3. And the third row 0, 0. Now you see 2 minus k minus k square. For the simplification, I will take outside the minus. I will take outside the minus. Then it become k square plus k minus 2. For our simplification, I will take first of all 1 outside minus. Then all the minus term become plus and the plus term become minus. But also you see in both the term minus is common. So I will take outside minus. So minus half k plus 2. Now you see it is a quadratic polynomial. Now I simplify this quadratic polynomial in factor form. K square plus k minus 2. When we multiply any two number we get minus 2. At the same time add we get coefficient of k is 1. So I write when we multiply any two number we get minus 2. At the same time add we get 1. What is the possibilities? 2 minus 1. 2 into minus 1 is minus 2. 2 minus 1 is plus 1. So outside one minus is there. How to write that factor? The quadratic polynomial start from k. So we write it is k plus 2. Outside this minus is there. Okay. Inside I write the quadratic polynomial in factor form. K plus 2. And another factor is minus 1. K minus 1. So outside minus. So when we multiply this, we get this quadratic polynomial. Now the outside minus is a product of these two terms is common. So I multiply the minus in any one other factor. Suppose minus 6 into 5 is there. I write it is either minus 6 into 5 or 6 into minus 5 is your choice. So it's a multiplication. So the minus multiply is in any one of the factor. Already you see 1k plus 2, 1 minus k, 1 minus k. Fact term is there. Already k plus 2 is there. Next step, I multiply this minus this factor. So it becomes k plus 2. I multiply inside here, so minus k plus 1. I write it is 1 minus k. Do you identify this step? I multiply this minus in any one other factor. Okay? It's not a 2 term, it's only 1 term. So this minus is multiply any one other factor. So k plus 2 I write, and I multiply the minus inside this factor. So minus into k, minus k. Minus into minus 1 is plus 1. So we write the values of minus of k square plus k minus 2 as k plus 2 into 1 minus k. For our easy convenient, I write this quadratic polynomial as the factor form k plus 2 into 1 minus k. So the augmented matrix A by B is equivalent to 1 minus 2 k 1 first row over second row 0 minus 2 of 1 minus k 1 minus k minus 3 third row 0 0. So this two element is 0. Now this factor will changes into k plus 2 into 1 minus k. So we simplify this factor k plus 2 into 1 minus k. And the third one minus of k plus 2. So actually it is the value of the augmented matrix. Now you see it is in echelon form. So it is in echelon form in the matrix sign. The first row is non-zero, and at least the triangle shape of element becomes 0. Now we put in which value of k. Okay, this matrix form is very important. We put in which value of k, the given system has no solution, unique and infinite many solution. We will take the first heading. I put a heading and then write no solution. We put in which value of a k, the given system has no solution. In rank method, when the system has no solution, the rank of the augmented matrix and the rank of the matrix A, both the ranks are is not is equal, that is a differ, then the system has no solution. So you see some values of k is there. We put in which value of a k, the given system has no solution. That is, the augmented matrix rank we need a 3. and this one matrix should be is equal to 2. We put in which value of k, that value becomes 0 and this value is a non-zero. Do you identify? It's your choice. We put any value of k, but our motive is to convert that element becomes 0. Okay, this element becomes 0 and that element is non-zero. Suppose this element is 0, the rank of A is 2. This element is non-zero, the rank of the matrix is 3. So we put in which value of k, the system has no solution. Do you identify? I say when our motive is this element becomes 0. So 1 minus k is equal to 0. So in this matrix form, whenever 1 minus k is there, I replace 1 minus k is 0. Which implies, what about k? Minus k becomes that side plus k. K is equal to 1. So in matrix form, whenever k is there, I replace the value of k is 1. First row, 1, minus 2, 1 more. Non-zero elements is there. Second one, 0. Minus 2 of 1 minus k is 0. 0, 0, but this element occur. Minus 3 is occur. 0, 0. We replace that value is 0. 0 anything is always 0. Minus half, the value of k is 1. 1 plus 2 is 3. So this element is non-zero and that element is 0. What is the rank of A by B? Rank of A by B means the row of A by B means the rank of the augmented matrix A by B. Rank means non-zero rows. First one non-zero. Second one, this 3 elements 0, but this element is non-zero. Third one is also this 3 elements 0, but this one is non-zero. So rank of A by B is 3. Next one also. What is the rank of A? Do you identify? We replace the value of k is 1. Whenever k is there, we replace the value of k is 1. First one, non-zero. So we consider these 3 rows, 3 column only. 1 minus 2, 1. Second one, 0, 0, 0. Second row fully vanished. Third row, 0, 0. This value is also 0. So what is the rank of A? Is just 1. Therefore, row of A by B here is not is equal to row of A, okay? Because row of A by B is 3 and row of A is 1. So both the ranks are different. Therefore, the system has no solution for the value of k is equal to 1. We must write the conclusion. Our question is for what values of k the given system has. The first solution is no solution. Therefore, the given system has no solution. Is a when or for k is equal to 1. We put in the solution system. Whenever k is there, we replace 1. The given system has no solution. I tell again. Whenever k is there, we replace k by 1 in this matrix. 1 minus 2, 1, 1. 0, 0, 0, minus 3. 0, 0, 0, minus 3. Then we check the rank. Row of A by B is 3 and row of A is just 1. Both the ranks are different. Therefore, the system has no solution. Our question is for what values of k. So you don't write 1 minus k equals 0. We write the values of k. When k is equal to 1, the given system has no solution. What is the second subdivision? The second subdivision is a unique solution. Okay, in a rank method, when the system has a unique solution, both the rank it should be equal and also it is equal to the number of unknowns. That means both the rank it should be 3. That is row of A by B and row of A fully is equal to 3, then the system has a unique solution. So we put in which values of a K, the given system has a unique solution. Here just we put the value K equal to 1 with some ranks. Now the motive is we need all our non-zero rows. First row, second row, third row. So we put in which value of K? We put so many values except 2 values. Suppose I put the value of K is equal to minus 2. K is equal to minus 2. Vanish, vanish. And the value of a K is equal to 1. That is 1 minus K is 0. Vanish, vanish. So except these 2 values, we put so many values. We gave a non-zero element. So in unique solution, I see the factors 1 minus K, 1 minus K, K plus 2, K plus 2. So in unique solution, we write when K plus 2 is not is equal to 0 and 1 minus K is not is equal to 0. This 2 factor is non-zero. I take K plus 2 and 1 minus K. K plus 2 is non-zero. What about K? The value of K is not is equal to plus 2 becomes that side minus 2. And this one 1 minus K is non-zero. So K value is not is equal to plus 1. Minus K becomes that side plus 1. So in this system, we replace the value of a K is not is equal to minus 2 and K is not is equal to 1. That means we put an infinite number of values of a K, we put except this 2. For example, I will take the value of K is except minus 2 and 1. The value of K is 0. The value of K is 0. First one non-zero. Second one 0, minus 2, 1, minus 3. Non-zero. 0, 0. The value of K is 0. 2, 1, 2, non-zero. 0, minus 2. So except these 2 values, we put so many values, it has some rank. So in this augmented matrix, K value is not is equal to minus 2 and K value is not is equal to 1 means we put the so many values of K except these 2 values. Then I say the rank of A by B is, what is the rank of A by B? Except these 2 values. We put so many values. It's a non-zero. Non-zero, non-zero, non-zero. All are non-zero. Therefore, row of A by B is 3. Also, what is row of A? The value of row of A is also 3. How? Because we consider this is a matrix A. It's a non-zero. Non-zero. Both are non-zero. So both are is equal to 3. Therefore, row of A by B is equal to row of A. Both the rank is equal to 3. It should be is equal to the given number of unknowns. Both the rank should be equal to 3. Where 3 is a given number of unknowns. That is x, y, z. Both the rank should be is equal to 3. Therefore, the system has unique solution. Okay. For the value of K is not is equal to minus 2 and the value of K is not is equal to 1. We must write the conclusion. Therefore, the system has unique solution. Okay, the system has unique solution. When or for when the value of a K is not is equal to minus 2 and the value of K is not is equal to 1. The given system has unique solution. Whenever the value of K is a minus 2 and also the value of K is not is equal to plus 1. We must indicate both the values. Suppose we indicate any one of the value. K is not is equal to minus 2. So I put the value of K is 1. This rank is different. So we must tell both the values. So these two, except these two values, the given system has unique solution. The third one is infinitely many solution. When the system has infinitely many solution. In the rank method, when the system has infinitely many solution, both the rank should be less than 3. Okay, it may be 2 or 1. The rank is reduced by 3, then the system has infinitely many solutions. So we put in which value of k. For our convenience, I again write the matrix. Now in this augmented matrix form, we put in which value of k, the rank is reduced by 3. You have any idea? We already 2 subdivisions over, now the third one is infinitely many solution. So the third row fully become vanish. Then only is possible the rank is less than 3. So we put the value of k is a 1 value or 2 value. Do you identify? I give one clue. We put only one value for k. Is enough. The rank is reduced by 3. You can see the third row. We put only one value of k. The third row fully becomes 0. Do you identify? You see this factor is common. K plus 2, k plus 2. Suppose this factor is vanish. This factor is also vanish. That is 0. So you don't consider the remaining 2 rows. Our motive is the rank is less than 3. So in this case, when the factor, first factor, k plus 2 is becomes 0. That means the value of a k plus 2 becomes that side minus 2. So now in augmented matrix form, whenever k is there, I replace k by minus 2. So first row become 1, minus 2, 1, non-zero row. Second row, 1, minus 2 of 1, minus of minus 2 is plus 2. So all the numbers are occur. So non-zero. 1, minus of minus 2, 3, minus 3. So there will be 2 non-zero. Now you see the third row. 0, 0. The value of k is minus 2. Minus 2 plus 2, 0. Minus 2 plus 2 is 0. What is the rank of A by B? I say the rank of A by B is 2. 1 non-zero row, 2 non-zero row. Okay, row of A by B is 2. Also, what is row of A? Row of A means rank of A. Will you don't consider the last column. 1, minus 2, minus 2. 0, minus 2 of 1, minus of minus 2, non-zero, non-zero. 2, 0, 0, that value is 0, minus 2 plus 2. So third row fully is 0. So rank is 2. Now you see both the ranks are first of all equal. And also the number 2 is less than the given number of unknown. Therefore, row of A by B is equal to row of A is equal to 2, where the number 2 is less than the given number of unknowns. Therefore, both the ranks are equal and also it is less than the given number of unknown. The system has infinitely many solutions. Infinitely many solutions when it is possible. The given system has infinitely many solutions for the value of a k is minus 2. For k, the value of k is minus 2. We must try the conclusion. Therefore, the given system has infinitely many solutions is possible only when the value of a k is exactly is equal to minus 2. In the same exercise, the third one is also you see the question. Investigate the values of lambda and nu. Investigate the values of lambda and nu. The system of linear equations 1, 2 and 3. 3 equations is given. You see some coefficient of y Z and the constant is lambda and nu. We put in which value of lambda and nu in this system as no solution, a unique solution and infinite number of solution as it is the previous one. The previous one we find the only one value of k. But you see here there will be two values. The values are lambda and nu. What is the first step in solution? To convert the given system of equation in matrix form. So the matrix form is the matrix form of the given system is, we form a matrices. The first matrix indicates the coefficients of x, y, z, and second matrix is the variable x, y, z is equal to RHS is the constant matrix. You know very well how to fill the matrices. The first row is the coefficient of x, y, z in the first equation. You see, it is the first equation. The coefficient of x is 2, y is 3, and z is 5. Second row, coefficient of x, y, z in the second equation. 7, 3, minus 5. Third equation, 2, 3, and the coefficient of z is lambda. So lambda. And here the variables x, y, and z. RHS is the constant in the given system of equations. In first equation RHS constant 9. Second equation is 8. And the third equation, what is the constant? Is nu. Now it is another form. Ax is equal to b. So it is a matrix A, it is X, and RHS is a matrix B. After writing in matrix form, what is the next step? To convert it in augmented matrix. The augmented matrix is, the augmented means extended is A by B. The matrix A is extended by the another matrix B, A by B. So first we write the values of A. The values of A, 2, 3, 5 first row. Second row, 7, 3, minus 5. Third row, 2, 3, lambda. So this one is extended by, B. The values of B. The values of B are 9, 8 and nu. We enter the value in A by B. 9, 8, nu. After writing the augmented matrix, the next step is to convert the augmented matrix in echelon form. Echelon means the first element is non-zero, and at least the triangle shape of element become 0. But you see 2, 7, 2. There is no possible to convert that element become 1. 2, 3, 5, 9. Suppose all are possible in the second table, we divide by 2, row 1. But it's only even number, all the remaining numbers are odd numbers. So no chance here to convert 2 as 1. No problem, we leave the first row as it is. So A by B. We do some operations, so it becomes equivalent. I write the first row as it is, 2, 3, 5 and 9. So no change in the first row. Second row. Our motive is to convert that element become 0. But 7, 2 is there. Both the number differ. Okay, we consider either R2 or R3. I consider R2 and R1. Our motive is to convert the number 7 becomes 0. But here 2 only is there in both R1 and R3. So I consider the first row and second row. How the number 7 become vanish? We already see in this kind of problems. Suppose the numbers are differ, we interchange the numbers in the rows. So first row fully multiplied by the number 7. And the second row fully multiplied by the number 2. So it becomes 14, 14. Then to separate it becomes 0. So how to write R2? I write R2 as Our motive is to convert that element become 0. R2 as 2 times of R2. We interchange the number. So 2 times of R2. Both have the same sign. So I separate. Minus the 7 times of R1. So 7 R1. So we write fully R2 as 2 times of R2 minus 7 times of R1. 7 number is there. We write R2 as 2R2. 2 7s are 14. Minus 7 2s are 14. 14 minus 14 is 0. Okay. Next element. 3. But we write R2 as 2R2. So 2 R2 value is 3. Minus 7. Whose corresponding value is here? 3. What is the final answer? 2 3s are 6 minus 21. 6 minus 21 is a minus 15. Okay, 6 minus 21 is minus 15. Minus 5 number is there. How to change the number 5? I already explained. We write R2 as 2R2. 2. The value of R2 is minus 5. According to our operation, minus 7 of the corresponding element of R1 is again plus 5. 2 into minus 5, minus 10, minus 7 5s are 35. Minus 10 minus 35 is a minus 45. Okay. The next number is 8. How to change the number 8? We write R2 as 2R2. 2. R2 value is here 8 minus 7. The corresponding value of R1 in 8 is 9. 2 is 16 minus 7 is 63. So 16 minus 63 is 63 is separated by a 16. 13 minus 6 is 7. We take one borrow, so 5. 5 minus 1 is 4. But the big number is minus. So minus 47. So second row over. Our motive is to convert that element is 0. But all the remaining elements is also important. So this element is over. The next step, to convert that element is also become 0. It's easy. We see the rows. We do one small simple process. The number 2 is automatically become 0. What is the process? You have any idea? We do one small work. The element 2 become 0. We consider R3 and R1. You see both the numbers are 2. Just we separate, that element become 0. So I write R3 as R3 minus R2. Third row minus the first two. Third row fully I write third row minus the first two. 2 minus 2, 0. 3 minus 3. Okay, 3 minus 3 is 0. How to write this one? We write R3 as R3 minus R1. R3 lambda minus corresponding element of R1 is 5. How to write? Lambda minus 5. Lambda minus 5. And the number new become, we write R3 as R3 minus R1. So new minus 9. New minus 9. So in this sum you see automatically that element is also become 0. In previous one, first we convert this element becomes 0. Then we converted this element becomes 0. But in this sum, is automatically that element is also become 0. Now you see it is in echelon form. Non-zero, and at least the triangle shape of element become 0. So now it is in echelon form. Now we go in order. Okay. You see again the question. The question is first one. The given system has no solution. So the next stating is no solution. I tell again in a rank method, when the system has no solution, both the ranks are differ. That is row of A by B is not is equal to row of A. So we put in which value of lambda are new. The given system has no solution. You see any idea? The first one is no solution. we put in which value of lambda and nu, the given system has no solution. That is, row of A by B, rank of A by B become 3. And the rank of A become just except 3. It may be 2 or 1. But lambda and nu occur only these two terms. So we say all the remaining terms, we know very well all are numbers. So we consider this two terms only. Our heading is no solution. So no solution means row of A by B is not is equal to row of A. So now this element is suppose 0 and that element is non-zero. Okay, this element becomes 0. This element is non-zero. Row of A by B is 3 and row of A is 2. So we vanish this element and this element is cannot be is not is equal to 0. So we put when lambda minus 5 is equal to 0. Okay, we make this element become 0 and nu minus 9 is not is equal to 0. Lambda minus 5 is equal to 0. That is, we vanish this element and nu minus 9 is not is equal to 0. But we need the value of lambda and nu. Lambda minus 5 is equal to 0 means the value of lambda is 5. And the value of nu is not is equal to plus 9. Minus 9 becomes that side plus 9. So in this augmented form, whenever lambda is there, we replace the value of lambda is 5. So that element becomes 0. And nu minus 9 is not is equal to 0. That means it has any value except 0. Then what is the rank of A by B? The rank of A by B means first non-zero row, second non-zero row, third row, 0, 0. This one is also 0. But that one is non-zero. Row of A by B is 3. Also, what is row of A? Row of A means rank of A. First row non-zero, second row non-zero, third row 0, 0. That value is also 0. So third row fully 0. So what is the rank? The rank is 2. Row of A is equal to 2. Therefore, row of A by B here is not is equal to row of A because both the ranks are differ. One is 3 and another one is 2. Therefore, the system has no solution for. The system has no solution for. In which value of lambda? 5. Lambda is equal to 5. And another value is also important. The value of nu is not is equal to 9. The system has no solution for lambda equal to 5 and nu is not is equal to 9. A system means the given 3 equations. So we combine the given 3 equations, we say it is a system. So the given system of equation or the system has no solution. The value of lambda is equal to 5 and the value of nu is not is equal to 9. The second subdivision is unique solution. When the given system has unique solution for what values of lambda and nu. You know very well, when the rank method, the system has a unique, both the rank should be is equal to 3. That is row of A by B and row of A should be is equal to 3. So we put in which value of lambda and nu, the system is 3. So in system is 3. So we tell any one other value. Suppose this one is non-zero. It may be 0 also. Okay. The system has both the rank is 3. This one is non-zero. Okay. This one is non-zero. This one is 0 or non-zero. You see the rank is 3. 1, 2. This one is non-zero. 3. Here is also considered. We take it is the rank is 3. You have any idea? So we find a unique solution that the element should be not is equal to 0, and whatever it may be the element, it may be a 0 or non-zero. So how to write? That element become non-zero. So when the system has a unique solution, when the value of lambda minus 5 is not is equal to 0. So this element is not is equal to 0, and whatever it may be the element, it may be a 0 or non-zero, and nu belongs to R. That is, we put any real number of nu. The real number nu, we put any real number. It may be 9. 9 is also a real number. 9 minus 9 is 0. No problem, because this one is non-zero. Or 0 is minus 9. We put any real number. This value is a 0 or non-zero. So lambda is not is equal to 5. Minus 5 becomes that side plus 5. And nu belongs to R, where nu is any real number. What is the row of A by B? Now the value of lambda is except to 5, is not is equal to 5. We put any value of 5. So here any value of 5. 1 non-zero, 2 non-zero, 3 non-zero, because this one is not is equal to 0. This may be 0 or non-zero. Row of A by B is 3. And also you see what is the row of A, rank of A? 1 non-zero, 2 non-zero. This one is also non-zero. So 0, 0, this one is non-zero. So both the rank is equal to 3. Row of A by B is 3. Also, row of A is equal to 3. Now you see both the ranks are equal. Therefore, row of A by B is equal to row of A. Both are is equal to 3, where 3 is nothing but the given number of unknowns. Therefore, the system has unique solution. Okay, therefore the system has a unique solution. When it is possible? When the value of lambda is not is equal to 5 and the value of nu, it may be any real number. Therefore the system has unique solution whenever the value of lambda is not is equal to 5 and the value of nu is belongs to R. We must write nu belongs to R. We don't put nu is equal to 9 or nu is not is equal to 9. So any value of nu, the rank cannot be changed. It may be nu value is 0, 9 like this. The rank cannot be changed. So we write in general. So nu belongs to R. So you don't tell nu minus 9 is equal to 0 or nu minus 9 is not is equal to 0. So we put any value, the rank cannot be changed. So we must indicate nu belongs to R. Therefore the system has unique solution for these two values. Exactly the value of lambda is except to 5. So we put except to 5 any real number. And the value of nu belongs to R. The third subdivision is infinitely many solution. In which value of lambda nu, the given system has infinitely many solution. You see again the augmented matrix. We put in which value of lambda nu, the given system has infinitely many solution. When the system has infinitely many solution, both the rank should be less than 3 and also equal. The rank it may be 2 or 1 of both A by B and E. So that means the third row fully vanished we need. That element is 0. This element is also 0. When this element becomes 0, we put the value of lambda is 5, that element becomes 0, vanish. And the value of nu is 9, this element is also vanish. So we put lambda minus 5 is 0. Nu minus 9 is also is equal to 0. Both the rank should be 2 I say. Is correct or not? First row non-zero row. Second zero row is also non-zero row. We put these two elements make 0. The third row fully 0. So we put lambda minus 5 is 0 and nu minus 9 is 0. So when lambda minus 5 is equal to 0 and nu minus 9 is also is equal to 0. That means what is the value of lambda? Minus 5 becomes that side plus 5 and the value of nu is also is equal to 9. Minus 9 becomes that side plus 9. Now in this system, okay, in this augmented form, we replace this value is 0 and that value is also 0. So what is the rank of A by B? First one non-zero row, second one non-zero row, third one 0, 0, this element 0, that element is also 0. So row of A by B is 2. And what is the rank of A? Rank of A means we don't consider the last column. 1 non-zero row, 2 non-zero row, third one is also 0. So row of A is also 2. Therefore, row of A by B is a 2. Because this two element exactly lambda is 5 and nu is equal to 9, the third row fully vanish. Also, what is the rank of A? Is also 2. Because lambda is 5, that one is also 0. Therefore, row of A by B is equal to row of A. Both the rank should be is equal to 2, where 2 is less than the given number of unknowns. 2 is less than the number of unknown is x, y, z. So in this case, the system has infinitely many solutions. Therefore, the system has infinitely many solutions. When the value of lambda is 5 and the value of lambda is 9. Right, when alpha, the given system has infinitely many solutions when lambda is equal to 5 and nu is equal to 9. The system has infinitely many solutions. We indicate when the value of lambda is 5 and the value of lambda is equal to 9. Okay students, today we see two sums. Both the sums involving rank method. Is an easy one if you work out one by one step. Suppose we do any one of the mistake, the answer will not come. So in both sums are important 5 more questions. The first one is to find the value of k and second one is to find the value of lambda and nu. So the sum is easy. We must memorize the formula of rank method. That is, when the system has unique, when the system has infinitely many solution, when the system has no solution. So very easy concepts. So first I write the formula in all the types. So you must memorize the formulas. Then you see the sums and also work out 1 or 2 times.